Hi, my name is Camille Branch, and this is Lab 3, Magnetic Field of a Bar Magnet. And then this is just a brief overview of what we'll be going over today. So, the introduction. The purpose of this lab is to compare the distance dependence of a magnetic field due to a small magnet to a calculated distance dependence using on and off magnetic field derived from the Biot-Savart law. Then we compare the experimental findings to a computational model. The fundamental principles in this experiment are the Biot-Savart law, which is the first equation below, distance dependence, which is the second equation below, and superposition. The main results of this lab is that we got n as about 1.5 and mu as negative 2.4. And then the model that we use for the computational model is closed script. So the experimental procedure. First, place a small barred magnet at the end of a meter stick. Using a magnetometer app, move your phone a horizontal and vertical distance away from the magnet to find the X and the Y peaks. When the peaks occur, mark those locations on your phone using tape, and you found the magnetometer on your phone. And so then we put that the distances we found like on our phone from the tape into an Excel sheet. And from that, we get that n is equal to about negative 2.4. We have a k value of 3.01 e to the negative 7. We say that b, or the net magnetic field, is equal to k divided by 2 mu divided by pi. And then we get that as 3.5 e to the negative 5. And then we have mu as 1.508. Okay, and then just analysis of our computational model. So basically, the magnetic field is calculated at 6 different locations around the magnet, and one location is on the axis, another one is off the axis, and then you have 4 that are calculated perpendicular to the axis, and that's represented by the R perp 1, 2, 3, and 4. And then when you run all that code, the values of the computations for the model is similar to what we have in the experimental results. Mainly, we find that B is similar to the net magnetic field that we got, and that's around like 3, I believe. And then some errors. During the experiment, we could have found that the location of the magnetometer was incorrect. We could have jotted down our data wrong and then put our tape wrong. The experiment could have been taking place near something that also has a magnetic field, maybe like through outlets or something metallic. Or the phone could have been oriented incorrectly when we were doing the experiment. Okay, and then what if you hadn't oriented your experiment to compensate for magnetic north and had instead laid out your meter stick at some intermediate angle with respect to the Earth's magnetic field? How would your results have changed? Well, the magnetic field of the magnet and the magnetic field of the Earth would no longer be perpendicular, and you wouldn't have to account for the effect of the magnetic field of Earth when you're doing the calculation for the magnetic field of the bar magnet. However, this would lead to like less accurate results. And then what if you were to stick 2 identical magnets together end to end and run the experiment again? How would you expect your measurements to differ? It would just make the net magnetic field of what we're like calculating for double, because you have double the magnets. And that's it. Thank you.